Okay. Good morning, everyone. I'm Tarun from Winthrop Engineering team, and I will be demoing and giving presentation on FSA test suite. I will be concentrating more on test suite and less on protocol as such. I have only one slide covering the protocol because Neil and Tom, they have already given overview of FSA. So I'll not give much presentation on FSA as such, but I'll dig more in test suite, how we are testing FSA as such. So agenda would be a brief overview of FSA and relationship to other protocols like SMB and SMB2. Then a test suite overview, like approach that we have used. Then adapters and sequence diagram. Then various scenarios that we have created, in FSA to test most of the requirements. And then one example, how we are validating the requirements. Then test environment and then demo. So I'll just start with overview of FSA. So FSA stands for File System Algorithm, and it's an informative reference which describes the communication between a server and its underlying object store. So if we see this diagram, so we receive, assume this is a server endpoint. We receive a request on SMB and SMB2 transport, and this channel shows, and FSA resides here, it's a file store object, and how SMB and SMB2 interact with FSA, all those processing rules are there in FSA document. So you can communicate with FSA using SMB or SMB2 as a transport. And why we have created FSA, why it's there. So with the advent of SMB2, it was realized that continuing to put file system specific semantic into each protocol document, like say SMB and SMB2, was not going to work. So as a result, most of the file system specific semantic was removed and replaced with references to FSA across SIFs, SMB and SMB2. So we have updated our document. All the document refers to FSA now, like SMB and SMB2. In all, FSA specifies 19 algorithms invoked by high layer applications and 14 common internal algorithms. FSA contains ADM in section 3.1.1, a library of common algorithm across operations in section 3.1.4, and an algorithmic description of wire visible operation, 3.1.5. This is what we are testing in FSA test suite, wire visible operation. So this is all about FSA. Now I'll move to FSA test suite. Are there any queries on FSA as such? Okay, so I'll proceed to test suite. Yeah.
In this context, what is an algorithm?
Okay, so I will open. So what I will do now during demo, I will open the technical document and show what I meant by algorithm. There's a pseudo code in FSA that says, okay, once I get a request from the client, okay, how I will validate each and every parameter. Okay, so algorithm is about how to validate parameter, when to return, what error code, and why it's happening, and all those stuff. So it has a detailed information. It's a big protocol, a big technical document of 207 pages, and it has all the algorithms. I'll show I'll just walk through the technical document so that you get a hint, what algorithms are all about. Okay. So now coming to test suite, so for test suite, we have adopted model-based testing approach. Primarily reason is it's a big protocol, like document, a complex document. It has a lot of processing rules, error checking, validation, and all other stuff. That's why we chose MBT approach, because it's quite efficient to use this approach rather than hand coding and using a traditional approach. And apart from that, we have various input parameters. Like for one operation, like application requesting and open a file, we have 10 parameters. And model-based testing can be used efficiently to generate parameter combinations of input parameters. And again, the third point is maintenance. Like whatever Keith covered yesterday, most of the points are applied to FSA. That's why we have chosen MBT approach for FSA. Now coming to architecture, like if we see this diagram, So we have two adapters. One is protocol adapter and one is transport adapter. Protocol adapter is specific to FSA. Whatever FSA says or states as far as error processing, pseudocode, all those implementation is there in FSA adapter. Transport adapter is just how we frame not frame also, how we send packet over the wire. So we use either SMB2 or SMB as a transport. So when I will walk through the code, we'll see how we have implemented the FSA adapter as such, and how we have implemented SMB and SMB2 adapter. And this is the architecture. Like we have chosen MBT approach, so we have Spec Explorer generating our model test cases. Then these test cases will interact with FSA adapter, and in turn, FSA adapter will frame the packet and send it to SUT either on SMB adapter, using SMB adapter or SMB2 adapter. And in PDF config file, we have a property to switch whether we want to use SMB or SMB2. So I'll move forward to the sequence diagram, like what happens in our test suite. So, like if we take an example of create file, model will generate test case for us for assume create file, and when we run this create file example, it will invoke adapter and it will send the abstract parameters to adapter layer. In adapter layer, like in protocol adapter layer, we'll convert those abstract parameters to real parameters that we want to send over the wire. I'll show that in my demo, how we are converting that. And then protocol adapter will decide whether I want to use SMB or SMB2 based on the setting we have done. And based on that, it will send the packet to SUT, will receive the reply, and based on the reply, it will pass that reply to protocol adapter, and protocol adapter will check whether the message is correct or not, and based on that, it will give feedback to model. And that's how the test case will get validated, whether the response is correct or not, whether sequence is correct or not. So all these things will be validated as a part of this entire sequence. Any questions till now? Okay, so I'll move forward. So scenarios. So in all, we have 17 scenarios in FSA to test the document as such. We have scenario for create file, open file, read file, and then we have for op logs and change notification and close, open, all. So we have created all these scenarios, and they cover different sections of document. Like if you go to document, we have different sections like what should we do when we receive a create file request? What should we do when we receive an open file request? So based on that, we have devised our scenarios, and we have validated them. Now I'll take a small example, how we are validating the requirement. Okay, so our requirement is in section 3.1.5.1 in FSA that the operation must be failed with this error under any of the following conditions. And the conditions are, if path name is not valid as specified in FSCC, or if path name contains a trailing backslash. Okay, so let's take an example of first one, if path name is invalid. Okay, so and let's go to our model first. I'll show that in demo also, but I have just captured it here. So this is how we write our scenario in config.cod that even Keith talked about yesterday. So this is how we write our calls in config.cod, and if you see this create file, we have taken abstraction here. Let's concentrate on the last parameter. We have said, okay, like we want to pass a parameter, or we want to pass a path name which is not valid. Okay, so right now our model doesn't know what is valid, what is invalid. Our model doesn't know what's the server name, what's the SUT, what's the valid part, and what's invalid part. Our adapter will convert this abstract parameter into a real parameter and will send it to the SUT. So that way, we are quite isolated. The only interface we share with our adapter is this interface, that's create file. So once our adapter publishes this interface, we cannot change that. So this is how we are working on abstract parameter right now, and later we'll convert into a real parameter. So this is how our scenario will look like in config.cod. This is how we write it, And when we explore, it will explore like this. Like, you are doing some initialization, then you are getting some configuration, and then you are calling a create file, and you are expecting this error from the server. Now, how this error came from, this is there in the document. And we have model our scenario like that, that we are expecting this error. Okay. So any questions? No. Okay. So I'll proceed forward. So I'll come to test environment. Like for this event, we are focusing only on workgroup environment. So we have a client, and we have Windows 2008 R2 as a server, and our test suite runs on a client machine, and we interact with Windows SUT, and we can do that with non-Windows SUT provided the implementation is there. Right. Now I'll give demo of model adapter PTF config file, how to run it, how to debug the test cases. So I'll switch my machine now. Okay. So if we see solution, we can see 3 layers here. One is adapter, one is model, and one is our test suite. Our test suite, it has some test cases which will be automatically generated by model. So these are not hand-coded as such. So first let's have a look at model, and this is our config.cod. And if we see this config.cod, and if we talk about that particular scenario, so this is that scenario right now. So we have said, okay, we want to create a file, but we want to pass an invalid parameter. So what will happen in this case? In this case, we're expecting an error from the server. Okay, but where have we stated that? It's not there right now. That how, like, what error we are expecting. So for that, we have to go to our model.cs where let me go up a bit. Where we have specified a rule saying, okay, if the file name is not valid, then we're expecting this error from the server. And I'll show if I change this, then what will happen. So right now, in this scenario, let's see how this will work. So I'll execute this test case. And let's see. So we expected invalid name, and we got invalid error from the server. So everything is working fine. Now let's say if something has changed in a document, and we want to modify our model, and how simple it is. So yeah, there is a learning curve, but once we learn modeling, then it's quite easy. Assuming now in protocol it's changed that if I send invalid path name, then I'm expecting maybe you can say access denied. Okay, so I've made change in my model. Now what I will do, I have to regenerate my test cases because I've modified my model. So I'll go exploration manager, and let me show the exploration first. So it's validating it right now. Now if we see, the sequence will remain same because we have not modified the sequence as such. But the key thing that has changed now is this access denied. If you see this access denied, previously it was invalid object. So this has changed now. And now we'll generate a test case for this. And that's also same. Just right click and say generate test code. And here you will see test case file where it will get generated. The path also. Yeah, so this file is regenerated. Okay. So I'll close this. Now let me run the same test case again. Okay, so it has failed this time, and that's expected as such. And the failure is that we're expecting access denied because we have changed our model and we have regenerated our test cases, but actually we are getting invalid, and that's a correct behavior as such. So this is how we change our model and we regenerate test cases. Like we don't have to hand code as such, and then we test the same test case. Okay, so I'll go and change this stuff. Okay. Now let's say we want to test this scenario, but there's some problem in this scenario, some exception or some unexpected error is coming from the server, and we want to debug it. So the simple thing is right click on this. Like if you are doing that from Visual Studio, not from command prompt. So from Visual Studio, you just say you can set a breakpoint here. Let me set it. Okay. We'll say, okay, debug the test case now. Okay, so my debugger, a breakpoint got hit, and I will directly go to this create file. So this test case got generated from model, and if you see from here, my adapter create file is getting invoked. So let's see how our abstract parameters are getting converted into a real parameters. So okay. So let's see the status. So in adapter, how we have coded is, okay, if you get path as invalid, like if you want to pass path as invalid, read this entry from PTF config file and send that file name in the call. So if we go to PTF config file, okay, so this is the path name or invalid file name that we are sending to the server right now, and it's expected to fail. So this is how we are converting our abstract parameters to actual parameter, real parameters. And after doing that, after converting all the abstract parameter to real parameters, let me show you how we are sending it. Okay, so we are framing SMB2 packet here, and whatever parameters we have passed, we are sending it to the server. So everything is synthetic here. If you want to change any value anywhere, like you can change it. It's in your hand right now. So we are not using Windows client as such. We have written our own synthetic layers. And if you go to references, let me show you. So we have included two references here, and these two references are coming from SMB2 protocol because we are using those protocols as transport. So that's how we send packet to server and we receive response, and we validate our request, our response as such. Let me say F5. Okay, so this test case passed, and so this is pretty much as far as adapter and model layers are concerned. I'll just quickly walk through a PDF config file. So we have a PDF config file here that should be changed based on on your deployment. Like if you are testing, like if your server name has changed, then you should change this entry. And there are other fields also that you should change based on your server, like whether you are testing against Windows Server, whether you are testing against non-Windows Server. If non-Windows Server, what are the credentials? And if you specify it incorrectly, then it will not work. You will see some other errors as such. So there are a couple of entries here that you have to modify. Some are optional, some are mandatory, like server name, credentials are mandatory. You have to change them, and some are optional. The biggest plus point with PDF config file is that it can be changed at runtime. So it's not that that if you change any entry, like let's see, if I change this entry here, I don't have to compile my code as such, because it will be pulled at runtime and dynamically, So now if I run this, I'm expecting a failure from the server, but I'm not compiled my code as such. Oh. Let me see. See, I might get a socket exception here because the server doesn't exist. No host, because I have changed the host name now. So there's no need to compile code as such. And if you want to capture network traffic just to see how server is behaving, I'll just show the traffic also. So this is the error we are getting from the server. Like if you want to analyze the traffic, how it's going, packet capture. So we send a create with embedded name, and we got this error from the server. So any questions as such about test suite? Because Keith is also there about modeling also, if you have any question. You were talking about algorithms, right?
Yeah.
But go ahead.
So it's the transport adapter that creates the actual file.
Yes. I can show you the code if you want. We frame a part of that packet, but after that it will be handed over to transport layer. So the entire logic will be in FSA adapter. And if you see this, it will go to transport adapter create file. And here we are using SMB2 or SMB as a transport. Right now we are using only SMB2. We'll frame SMB2 packet, and then we'll send that packet to the server. And here we will create that packet. But the parameters are passed from FSA adapter. And coming back to your earlier question regarding the algorithms, let me switch. I have this document open on my desktop. So this is the pseudocode of the algorithm that's mentioned in FSA. Like, okay, if you receive a creation of new file request, what you should do. And the similar thing I'll say we are emulating in our model also. Like, this is what you should do. And if I show you our model, so this is the algorithm. And there are different algorithms. Let me scroll down. This is common algorithms, how to report a change and how to detect if an open file exists within a directory. Okay, so this is the entire algorithm that's like, once you received an input, how to validate that input and how to check. Does that answer your question? Okay, and I'll just go to my model. So we have common algorithms, right, in our technical document, and like these are all the algorithms that we have implemented at client end using model, just to make sure everything is working fine. And based on that, we decide, okay, what error we are expecting from the server, because for this model we use technical document, and if there's any mismatch in the on-wire behavior and the implementation, then it will be caught easily. Yeah, please go ahead.
Question about generating the package directly on the wire as opposed to the real application that interact with the redirect between and packets and wire. How are the differences?
So your question is, how different are our packets from normal Windows client?
That and how does the behavior change from the different sequence of packets and now?
Okay, so the follow-up question is, how sequence of packet and how the behavior change as such. So let's treat our test suite as an application itself, and because it will not impact Windows client as such, because we are not passing these packets to Windows client. It's our client application that's sending packet to server and receiving it and processing it. The benefit with this is like we have more granular control over packet. Like if you want, you can change any bit or any byte of the packet. With Windows client you don't have that control as such. Because you have limited interfaces and you have to use only those interfaces. With this, like if you want to pass any argument that server doesn't support, or maybe server supports, but maybe your server doesn't support, okay, you can do that easily. You just flip that bit or maybe that byte. You go and change the adapter the packet that's formulated in adapter, and that way you will have more control. But as far as sequences are concerned, Windows client might send only limited sequences. With this, like you can say, okay, I will send session setup before negotiate. Windows client will never do that in idle scenario. You can do some stuff, but Windows client will never do that. Our application can do that. So in that case, you have a scenario where you have sent session setup before negotiate. Ideally, like on Windows against Windows SUT, we are expecting a failure because you didn't negotiate on dialect as such, but on your server it might pass. So there could be a bug there, right? So that sort of a control we have with using test suites as such. But as far as packet format is concerned, there's no difference, because once we frame SMB2 packet, we'll send it to on TCP layer. So there's no difference in packets as such. Any other questions? Okay. So we are pretty much done, Daryl. Should we break for lunch?
Any other questions on FSA? Oh, I did forget to introduce Craig. Craig Barkhouse, right?
Yeah.
Craig's here from the product team. He works on file systems.
I did a lot of work on FSA. I wrote that open.
Okay.
Looks
Good that you are here.
So in addition to the slides from the SNIA FDC from last year, SDC from last year with Neil Christian's presentation, we had the FSA presentation here at the Plugfest. That's recorded on channel 9 under MSFSA. So that is available for reference as well. That was on specifically on the document as opposed to
Test
looking
suite.
at the test suite and the details. Come on up. We've
Okay.
talked a little bit about the Plugfest for
You can always go
SNIA
break for
SDC.
lunch if you want.
That's right.
I'm S.W. Worth. I'm a Microsoft employee. I'm on the board of directors of the Storage Networking Industry Association, and I'm the co-chair of a conference in September called Storage Developer Conference, which SNIA owns and runs. It's at the Hyatt in Santa Clara. Co-located with that is the SNIA SIFS SMB SMB2 Plugfest. I know many of you have already been at that event. You should be nodding your heads and already have the dates allocated for that. Those who are not familiar with SDC, you can go to storagedeveloper.org and look up the agenda. You can see the presentations from the past few years. The demographic is people like you and people like you. About 300 to 350 people. The Plugfest starts on Sunday morning and goes through Thursday afternoon. It's 24 hours a day. We have plenty of caffeinated beverages, and we expect you to be in there testing. We do have a rule that you shower at least every 48 hours because of some past occurrences. But this is a pretty geeky event. You'll feel very comfortable there. The presentations, again, starting on Monday morning, there are a solid track of 16 presentations of SIFS, SMB, SMB2. There's also other file protocols, 4 sessions on NFS this year, including PNFS. There's also a strong session of 12 file systems talks, so everything from ButterFS to, we hope, ZFS, mostly by leading presenters. And the Plugfest, if you participate in the Plugfest, Microsoft underwrites this. Each company gets 2 full conference passes to SDC for free by participating in the Plugfest. Don't just drop your gear and go to the sessions. You got to actually participate. We did have a company that did that one year, and we auctioned off their gear when they weren't there. So we'd like you to come. It's a pretty cool event. The cost, once you run over that amount of people, is only $495. As long as you're participating in the Plugfest. If you're not participating in the Plugfest, it's like $1,300 or something like that. But Silicon Valley, third week of September. What am I missing? Oh, and cool T-shirts. Always have cool T-shirts. I don't have the
Yet to be determined.
yeah, I don't have the current one, but this is from a couple years ago. And last year was the state diagram for the SMB 2.1 protocol with a few extra modifications.
And the smiley face was a dead giveaway.
Yeah,
And
you
no,
know.
SW claims it's a TDI.
Actually, this one, once we printed it on the T-shirt, then the technical council came back and filed a bug on that section of the documentation. So we're
Actually, they filed a bug on that very sentence, and we had to change it.
there you go, the voice of experience coming through here. So, pretty cool event. If you want more details, I'd be happy to talk about it on and on and on and on until you're drained of will and you will show up and be excited about it. But pretty cool event, and we'd like to see you there. Thanks.
Great. Thank you, SW.